Assalamualaikum everyone. We're going to continue our lecture on boost converter. So this time we're going to draw the boost converter waveform. Okay. So this slide shows the overall. Okay, but we're going to derive it one by one. Okay, right. So do you still remember our boost converter? Okay. Alright. So do you still remember we have a Vs and then we have the inductor and we have a switch. Alright, then we have a diode. Okay, and we have a capacitor. Okay, then we have a load and we have a plus minus V out. Okay, so here is the IL and this is the direction of the ID and here is the direction of your IS. Sorry. Okay, it depends, yeah. The direction of the IS, it depends on which mode. Okay, so you know, so I just gonna draw like that. Okay, the IS. Okay, and you know that this is your plus minus VL. Okay, the voltage across the inductor. Okay, right. So from here, we're going to derive a waveform. Okay. And then remember the switch on and switch off. Okay. So that is quite important. Okay, so we're going to divide. Okay, we have a switch on and switch off mode. Okay, right. So the first waveform that we're going to draw is the switch. Still remember the switch? This part? Yeah, S. That is the switch. Okay, so when the switch is on, okay, on is 1, yeah? This is on. It's always at 1 or 0. Okay, then we have the second mode when the switch is off. Sorry. Okay, when the switch is 0. Okay, that is off. And then, of course, it repeats again. Okay, when the switch is on, and again when the switch is off. So here's on and off again. 2 cycle, yeah? Okay, right. Next, we want to have a look at the Vs. You will see that Vs is also the same as VL. Okay, so alright, so here, okay, Vs is equal when the switch is on. Okay, remember previously we said that when the switch mode is on, the V equals to Vs equals to VL. Okay, so when it's at the off mode, we say that okay, the VL now become negative Vs minus V naught. Okay, and the waveform repeats itself again. Okay, right. So now we want to draw IL. Okay, I think these two. Slow it down. Okay, right. So now we want to draw IL waveform. Okay, so if we go back, IL is this one. Okay, the current across the inductor here. Okay, So remember when we derive when we derive VL equals to IL over the IDT, yeah, and then we derive the IDT, remember, yeah, the previous class. Okay, we say that VL over IL, sorry, not IL, this is L, yeah, over L. Okay, so this basically the slope of the IL. Okay, so when the switch is on, we seen that from the previous class. Okay, the slope is positive, and then when the switch is off, the slope is negative. Okay, again it repeats, positive and negative. Okay, so that is IL. Okay, we call this point, is IL mean. Yeah, and then we call this point here as IL max. Okay, all right, and then do you still remember that the average of that, okay, is the I out. I out is the average of the IL. Okay, so that is IL, and then next we want to draw IS. Okay, so if you see here at the circuit, okay, so you see IS, okay, when the switch is on, when the switch is on, okay, so the switch become short circuit, yeah, all right, so means that, okay, IL at this time is the same as IS. Okay, this relationship, when this is when the switch is on. Okay, all right, so because you know why, because the diode becomes the reverse bias, so that's why you get IL equals to IS. So means that the slope of IS will follow the IL because it's the same. Okay, so that's what we get, this one. Okay, so when the switch is off, okay, now we're going to mode 2. Okay, you will see that the switch become a open circuit, so there's no current flow here, so that's why it's 0. Okay, so it repeats again, when the switch is on, the IS equals to IL, so it follows the IL slope. Alright, then it goes to 0 again, because now when the switch is off, okay, what happened when the switch is off, the switch become open circuit, so there's no IS. No IS means 0. Okay, right, so we're moving on. Okay, now we want to draw ID. Okay, ID is a diode current. Okay, now we want to draw ID. Okay, right. Before we actually draw ID, I would like to redraw again the IL, because IL is actually a very important waveform because it's a benchmark to ID and also IS. Okay, so let's redraw the IL. Okay, so then we can easily determine our ID. Okay, as you remember, this is when the S is on, this is when the S is off. Okay, so what I mean by that is like this. Okay, what I mean by that is, okay, from this time to this time the S is on, from this time to this time the S is off. S means switch, yeah, S means switch. Alright, so ID. So when now, okay, if you remember the circuit, okay, we have the Vs, and then we have the inductor, and we have the switch. Okay, alright, then we have the diode, then we have a capacitor, and then we have the load. Okay, the load is plus minus the out. Okay guys, so if you have a look here, okay, when during the switch is off, alright, so when the switch is on, okay, this part become a short circuit, okay, connecting. So what happened to the diode? The diode is off, yeah. So once the diode is reverse bias, okay, it become a, this is when the switch is on. So the diode become a reverse bias, so it become an open circuit here. So if you see here again, the IL now the same with the IS. That's what I mean with my previous slide. IS equals to IS during the switch on. Okay, so you see here now the ID is 0. Okay, so if we go back to our here, so means that we start when the switch is on, the ID is 0, nothing. Okay, alright, but then if we go have a look at when the switch is now open circuit, yeah, so means that the switch now is off. Okay, the diode become a forward bias, so it become a short circuit, so it can conduct current. Yes. Okay, so now if you have a look at your ID now, okay, so ID now when the switch is off, okay, you will see that your IL now equals to your ID, and your IS now is 0. Okay, so now if you see, let's go back to the waveform. Okay, you will say, you will agree with me if I say now my IL, my ID follows the slope of the IL. Okay, and again when the switch is on, my ID is 0, and when the switch is off, the slope follow the IL. Okay, that is the ID. Okay, now let's draw IC. Okay, IC. So if we go back to the circuit, okay, so this is the IC. So remember KCL? Yeah, KCL says that, okay, in ID, IC plus I0. Okay, so this your ID, that's your IC, that's your I0. Okay, alright. So if I say IC now, okay, I reshuffle the equation and become ID minus I0, right? Okay, so from the previous slide just now, we says that we define I0 as the average. Okay, so take that, okay, for every point, okay, of ID, you minus with the I0 just now, okay, all right, and you can derive your IC waveform, okay, then you will get something like this. Okay, that's your IC. Okay, so that's all for the boost converter waveform. So next, we want to move on to the duty cycle. Okay, all right. So for boost converter duty cycle, sorry, for the boost converter duty cycle, I'm just going to give you directly the formula. Okay, it's this one. Okay, you have to remember again, for every converter, the derivation of the duty cycle or the ratio of the V out divided by Vs is always different. Okay, so make sure that you memorize, okay, the ratio of the V out and the input voltage for each of the converter.